Hi, welcome to Physics Teacher. Blocks attached to pulleys on inclines with friction are common questions you're going to see in grade 12 physics. So I thought, let's go over this one together. So here's our problem. We have two masses connected by a rope over a pulley, where one of them is along a rough surface with a coefficient of kinetic friction of 0.2, and where the incline is inclined at 30 degrees. And we need to find the acceleration of the system, or just the acceleration of one of these blocks. So let's look at this block. It's going to be moving up the ramp. That's where it's going to accelerate. So we should always choose our positive direction to be in the same direction as acceleration. This avoids us getting any negative accelerations. Right? Our pulley will rotate our coordinate system, so we'll have our positive direction like so. Now this we'll call our positive x direction, and so we'll also have a positive y direction for this block over here. Alright, so now that we have our coordinates, let's draw all of our forces. So over here on this block, we're going to have a force of gravity. Let's call this block number 1. So we're going to have Fg1. And we're also going to have a tension force. But that tension force is going to be equal and opposite to this tension force. So if we're considering this entire system, then those will be internal forces that won't really matter. Then if it's sliding up the ramp, we will have some kinetic friction opposing that motion. So let's call this Fk, and this will be block 2. It will have a normal force perpendicular to that surface, Fn, and it will have gravity going straight down. We'll call this Fg2. Alright, now since this gravity is not parallel to either of our coordinates, let's write components for this. So we are going to have a y component, and we are going to have an x component, where this is our 90-degree angle and this is our 30-degree angle. Alright, so we're ready to apply Newton's second law, which says the sum of all forces acting on the system is going to equal to the mass of the whole system. So that's our two blocks. So let's have both m1 plus m2 times acceleration. Alright, so let's look at all these forces. What are all the forces that are acting on our combined two blocks? So first we have Fg1. So let's write Fg1, and it's in our positive direction. So Fg1. Now our tension, internal forces, if you want to write them you can, but you'll just have Ft minus Ft, and they're going to cancel. We have a negative force of friction, so minus Fk for that second block. And then we have a negative component of gravity in our x direction, so minus F, G2 in x. So these are all of our forces in x, which show us our acceleration in x. Now because we've chosen our x direction to be in the same direction as acceleration, we know that ax is simply equal to a. That's what makes it so simple to choose that kind of coordinate system. And this will all equal m1 plus m2 times a. Alright, so now let's calculate one by one what each of these forces are. So Fg1, that just equals mass 1 times gravity. Okay. And Fk, our equation is mu k, times the force of normal. Well, let's come back to that. For now, let's look at Fg2. So Fg2, and its x component is right here. That is going to equal m2g. And since this is opposite our angle, it's going to be the sine of theta. So minus m2g sine of theta. And that all equals m1 plus m2 times a. Alright, so let's go back and look at this normal force here. What's that normal force going to be? Now, if you look at it carefully, you'll see that the normal force and this y component of gravity are the only vectors in our y component. And because our block does not accelerate in y, then these vectors must be equal and opposite to each other. So the normal force will then be equal to m2g cos theta. Alright, so let's rewrite this out then. So we have m1g minus mu k, where Fn is m2g cos theta, minus m2g sine theta, and that'll equal the sum of our masses for our system times acceleration. Now we simply need to divide both sides by the sum of the masses, and we will then have isolated for acceleration. So now we start plugging in numbers. We could have plugged in numbers before, but I always tell my students to try and do numbers as late as you can. Right? Work with the letters. So here we have mass 1, which is 8 kilograms, times gravity, which is 9.8 newtons per kilogram. Subtract mu k, which is 0.2, times m2, so we have 4 kilograms, times 9.8 newtons per kilogram. I am going to run out of space. Times the cos of 30 degrees. And then we're going to minus m2 again. So that is 4 kilograms times g, which is 9.8 newtons per kilogram, but I'm running out of space, times by the sine of 30 degrees, all divided by m1 plus m2. So 8 kilograms plus 4 kilograms gives us 12 kilograms. And that's going to give us an acceleration of 4.3 meters per second squared. All right, I hope that helped. And if you still have any questions, let me know in the comments.